Good morning, girls. Today's lesson is chapter 7, lesson 6, and the title is Choosing a Factoring Method. So far in this chapter, you learned many methods of factoring, and let's recall each one of them in a very quick way. For example, first method was by GCF, which is the easiest one. You take what is common. For example, here if you have 2x plus 6, you see that 2 is common, so you cross it and you put it outside, and the rest you put it inside. The second method you learned is if you have an expression of the form x power 2 plus bx plus c. We were looking for two numbers. If I multiply them, it will give me c, and if I added them, it will give me b, and then so on. The third method is when you have an expression with ax power 2 plus bx plus c. We were looking for two numbers. If you multiply them, it will give you a times c, and if you add them, it will be b. And then when you found them, you remember we were separating bx and so on. The fourth way is if you have a perfect square. This is the general formula of a perfect square. If you have a squared plus 2ab plus b squared, it will be a plus b all together power 2. And here, if it was a minus, here you have a minus. For example, this one. If you have x power 2 plus 6x plus 9, so we said that 9 is 3 power 2. So we put x here, and 3 we put it here, and you put a power 2 outside. This is called perfect square. The last method you learned was difference of two squares. If you have, for example, a power 2 minus b power 2, so you put a minus b, a plus b. First minus second, first plus second. For example, this one, x squared minus 16. Since 16 is 4 power 2, so we put it x minus 4 and x plus 4. These are all the ways you've learned so far and all the methods of factoring. The good thing about this lesson is that you're not going to learn a new method. It's just you have to remember all of these methods. So they were gonna give you an expression, and you have to keep in your mind all these methods, and you have to match which is the best method to solve the expression they gave you. Okay, so let's see how is it going to be. For example, in example 1, they gave you factored forms. For example, 2x into x power 2 plus b. They asked you, is it completely factored? So you have to figure out if they are completely factored. Let's see. 2x, and here I have x power 2 plus b. Can I do anything about this? Can I factor it in any way? Like, for example, if I have x times x, and this is 2 times 2, can I take common? Like, can I use this one? No, there is nothing common here. So actually this is completely factored. But what if instead of plus they gave you minus? If you look at x power 2 minus 4, this will remind you of this method, difference of two squares. It's like this one. So you can put it as first plus second, first minus second. And of course, there is a 2x here. 4, taking into consideration that 2 is power 2, so I put it x minus 2 and x plus 2. This is a power 2. Okay, so you have to recall this method in order to continue here. So this was if a completely factored form. No, it wasn't completely factored. We just factored it now. What if they gave you, for example, 2x plus 6 into x plus 5. Look at this, you cannot do anything with it. But this one, you can notice that 2 is common, right? So here you can use this way, GCF way, which is you take the common, which is 2, you put it outside, and the rest you put it inside. So by this, you continued factoring it. It wasn't completely factored. Let me give you, for example, one more example. What if you have 2 into 4x power 3 minus 3x power 2 minus 8x? Now look, is there a common here? I can see that x is common. So I'll take x outside, and inside you will put what is left. Here I took x from x power 3, so it became x power 2. And here 1x is left, and here no x is left, so only 8. No need for this parentheses. This one, can I factor it more? Do I have any common? No. So was it completely factored? No, it wasn't. And this is how you continue factoring it. So simply, this is example 1. You just have to say if it is completely factored or no. And if no, you have to continue factoring it using these methods that you can see here.